Hi, this is Miss Sandy, and this is a family letter for the parents, or guardians, about the mathematics in this unit. Dear family, our class is starting a new mathematics unit about multiplication. In this unit, students review multiplication facts and solve problems by using arrays, such as the examples below. They also solve problems about factors of a number and number relationships, such as this one. If 25 is a factor of 100, will 25 also be a factor of 300? How do you know? Students are introduced to multiplicative comparison problems. Throughout this unit, students will be working toward these goals. We have benchmark goals and we have examples. So in the problem here, the benchmark goal is to use multiplication to solve multiplicative comparison problems. And in the example, we have Franco's daughter is 2 feet tall. Franco is 3 times as tall as his daughter. How tall is he? So a big part of these problems is to decode the words and turn them into number sentences. So I'm going to take a minute. We're going to take a look at what we have in the words. Okay, so we have Franco's daughter is 2 feet tall. So there's a little model of the daughter. And there's a little scale that says she's 2 feet. Okay. And the second part of it, Franco is 3 times as tall as his daughter. So his daughter's 2 feet. Franco is 3 times as tall, which means 3 times. We're going to use multiplication there. And his daughter is 2 feet tall. So 3 times 2 would equal 6. So 6 would be our solution there. Okay, and in the model here we have the father, Franco. Okay, and he's being described in 3 segments. So here is 2 feet, here's another 2 feet, and here's the third 2 feet. Alright, so that's what the model is showing. The daughter is 2 feet tall, the father's 3 times 1, 2, 3, as tall as the daughter is. Okay? So that's what we have for our model. Let's take a look at the picture they drew. Alright, so in this model we have the little girl again. She's 2 feet tall. The dad is 3 times as tall, so we know we're using multiplication. So 3 times 2, 2 represents the height of the daughter, and 3 times 2 would equal 6. So we have 2, 4, 6. The dad, Franco, is 6 feet tall. Okay, so that's one strategy to kind of help you. Okay, and then the next one is determine whether numbers up to 100 are prime or composite. Is 49 prime or composite, and how do you know? Okay, so let's take a look at prime and composite numbers. Okay, so a prime number is a number that has only 2 factors, 1 and itself. If those are the only 2 factors of a number, then that number is prime. Okay? When a number is composite, it has more than those factors. Okay, so let's take a look at 1. The things that make up 1 is 1 times 1. 1 times 1 equals 1. The only factors of 1 is 1 in itself. So that would be a prime number. Okay, let's take a look at the number 2. 1 times 2 makes a 2. And the only other factors of 1 and 2 are 1 and 2. So that one's a prime number. Let's take a look at 3. Factors of 3 are 1 times 3. 1 times 3 equals 3. This one is also a prime number because there's no other factors that multiply to make a 3. Now let's take a look at 4, and you're going to see the pattern change. Factors of 4 are 1 times 4 and 2 times 2. 1 times 4 equals 4, and 2 times 2 equals 4. Okay, so this 4 is composite because of the fact that there is more than 1 in itself as a factor set. Okay, let's take a look at 5. 1 times 5 equals 5. That's the only factors, only two things that multiply to get a 5. So that one's prime. Let's look at 6. Factors of 6 are 1 times 6. That equals 6. And 2 times 3. That also equals 6. So 6 is considered composite because it has more than one factor set that makes it. All right, let's take a look at 7. Factors of 7 are 1 times 7. 1 times 7 equals 7. That's the only factors of 7. So 1 times 7 is the only way you can multiply to get a 7. So that one's prime. Let's take a look at 8. So 1 times 8 is 8. And 2 times 4 is 8. Okay. So this one is composite. Let's take a look at 9. 1 times 9 equals 9, and 3 times 3 equals 9. So this one, 9, is composite. Let's take a look at 10. 1 times 10 equals 10. 2 times 5 equals 10. So more than one factor, so this one's composite. Let's take a look at 11. 1 times 11 equals 11, and those are the only factors that you can multiply to get an 11, so this one is prime. And 12. Let's take a look at 12. So we have 1 times 12, that equals 12. And then 12 is even, so we know we could go 2 times 6, which would equal 12. And we could also go 3 times 4, which equals 12. So that makes 12 composite. It's comprised of other factors just other than 1 in itself. And when it's 1 in itself, then it's prime. Okay, so that's a brief introduction to prime numbers and composite numbers, and I hope that helps.